Good afternoon, everyone. I hope you're doing great. If you can hear me clearly, please type 1. Thank you very much. Justin, Akoreda, Kylie, Sherry, Mohari, okay, and all the others. Good afternoon. I hope you're doing great. Please go to your course content, and you can see that there is week number 12. You can either download the first 4 files separately, or the last file contains everything together in a zip file. The other option is you can download the file that I have already uploaded in the chat box. So please take your time, download the zip file or the files, and when you are done, please type 2. Thank you, Kylie, Matthew, Sherry. Also, for those who want to check the @class code, here is the code. Would you please just save it for people who come later and they query about this? First, make sure that it works. If it works, please give me a feedback. Thank you. Thank you, Matthew. So among the files that we have, and don't worry, I'm going to give you exactly the same structure that you see on my computer. So you're going to have all in one pretty soon at the end of week number 14, sorry. So before the midterm exam, you're going to have this one to help you to review the content as quickly as possible. The very first file is week 12 Python A. Drag and drop that into Colab. This is actually a zip file that I have sent to you. So it takes a few seconds to show you something similar to that. Good afternoon, Murad. And then you see you have animal class.py. Please drag and drop this file here and ignore the warning. It just wants to tell you you're not going to have it next time. And if you see similar setting that I have on my screen, and I try to zoom it a little bit, so later when you want to access the recorded video, so you do not have any struggle. Okay. The other thing before I continue is every video that I upload, it takes quite a while to get to the maximum quality, which is 4K. So it takes a few hours, like 4 to 5. So if you see that it is kind of blurry and it's not very clear, please wait for a couple of hours, and then when you reach the file, you can see everything is fine. I have provided 3 different video files, but time permitting, we can just watch one of them. to accelerate and to speed up the process of learning the concept, I borrowed the things that the gentleman explained in the second video, and we are gonna cover them today. But please watch it at your convenience if you want to elaborate more, if you want to dive deeper into the content the way that the gentleman explained. But we are going to cover everything from there. The slides that the original book provides for us, I found it not very much self-explanatory. So that is why I changed a bit, well, changed a lot, borrowing from different resources, and you have the materials. But let's kick it off by watching this video together. Those who want, my apologies, one of the ways that came to my mind for those who want to watch it with higher quality and not relying on the video that I share now would be just mute the screen for a couple of minutes, for 13 minutes roughly. And then after that, please come back to the screen and you can follow here. You can send that to your phone or to your tablet or anything and start watching it. While you mute, you just turn off the volume of this, okay? So let's watch this one together. It's a very nice explanation.
What's up, you guys? Welcome back to another Code with Kylie video. I'm Kylie and I'm still filming from the floor today because I still am part of No Death Squad. Anyways, we're talking about inheritance and polymorphism. These are big words, but I promise you that they're actually very helpful concepts in object-oriented programming that will help you make your code more concise and more flexible. So let's just dive right into it. Inheritance basically allows us to create new classes known as child classes based off of an existing class known as a parent class. And just as the name implies, the child class will actually inherit the attributes and functions of the parent class. This is really good for organization and avoiding duplication of code. If you have two very, very similar classes, then you can put all the similarities into the parent class and have these child classes basically be branches of those. Okay, so of course, let's use an example, and you guys all know that I really love dogs. So I'm gonna use dogs as my example. All right, I wanna come up with some classes to represent various breeds of dogs. For example, Samoyeds, Poodles, and Golden Retrievers. So if I wanted to, I could define everything like this. So once I've defined all of these, I'm gonna initialize them. Of course, we have to add self in there. And let's say for simplicity, we're just gonna give all these dogs a name. So self.name equals name. And this is gonna go through all of these like this. Right off the bat, you can see that we have the same initialization function literally copy and pasted 3 times. In addition, if we had another function like swaps, and of course, all of our doggos like Wacos, so we are going to paste these everywhere. So what we're seeing here is a lot of code repetition because these two functions are basically copy and pasted for all 3 of these dogs. If we take a step back and we think about this in real life, well, Samoyeds, Poodles, and Golden Retrievers, they're all a breed of dog. So what we can do in Python is we can actually add a parent class to all of these classes, which unifies them as that type of object. We can create a superclass called dog, which basically would have all the properties and functions of a dog to share among all of the breeds. So here we can say init, and then we can give it even other things like age, friendliness, etc. And here, let's do self.name equals name, self.age. We're just initializing all of these attributes within our class. All the doggos like the Wacos, so we're doing likes, walks, self. and this is true. Okay, so now that we have the superclass, remember what we said about how inheritance basically allows the child class to inherit from the parent class? All we would have to do is classify our 3 breeds as child classes of dog. And how do we do that? Here in our class definition, all we have to add is parentheses, and then within the parentheses, the parent. So here we have Samoyed, and then this basically means Samoyed is a child class of dog. And here we can even erase this. And of course, we would input the name, age, and friendliness, but then down here, instead of reinitializing the exact same thing, we don't have to copy and paste that code. Instead, we can just do super, and this means call the superclass dot init. So here this is saying in the superclass, call this initialization function, and then we're gonna pass in the parameters that belong up here. So that's name, age, and friendliness. And then I'm gonna do that with all my doggos down here. And change these so that they are now subclasses of dogs. Ta-da! Alright, so let me just show you guys how this works. You can see that in Samoyed, we haven't defined likes walks. But if I create Sammy the Samoyed, and I pass in a name, so Sammy, an age, 2, maybe, and then friendliness, let's do a scale of 1 to 10, let's say 10. Let's say that Sammy is 10 out of 10 friendly. Okay, so now what we can do is we can print Sammy dot name, Sammy dot age, and Sammy dot friendliness. Okay, so we see that for Sammy, we get that the name is Sammy, the age is 2, and Sammy's friendliness is a 10 out of 10. So here, this initialization function has actually called this one up here to set the attributes. Okay, so one other cool thing is we can actually print Sammy.likeswalks. And again, we haven't actually defined likeswalks as a method under Samoyed, but we have in the superclass. And now you can see that it will actually inherit from that superclass, so we can actually call this function likeswalks. Okay, so look, it's true. And just like in real life, we can also have mixes of these dogs, which would mean that we have more than one parent. So this is something called multiple inheritance, where you can have more than one superclass. And the child class would actually inherit all the properties and attributes of all the parent classes. So here, if I want to create a golden doodle, maybe, then I can say golden doodle, and this is going to inherit from poodle and golden retriever. And of course, we initialize this, just like how we initialize these other things. Let's call this golden doodle Goldie. Goldie the golden doodle. And Goldie age, let's do 1. And friendliness, man, 10 out of 10, of course. We can print these things again. And we see that Goldie is age 1, friendliness 10 out of 10, and likes walks. All right, so one reason that we might want to define golden doodle with poodle and golden retriever as separate classes is because maybe poodles and golden retrievers both have property that we actually want to pass down into this golden doodle. So for example, our shedding amount. Well, poodles don't shed, so here we're going to return 0. And then for golden retriever, let's do one that's like define fetch ability. And this is a method. So let's say the self.age is less than 2. Maybe the golden retriever is not that great at fetching yet, so we'll give it an 8 out of 10. So return 8. But let's say else if the age is less than 10, so this is maybe something between 2 and 10, we can return 10 out of 10. And then otherwise, which means that it would actually be older than 10, we can return 7, because maybe they're a little bit slow, I don't really know. So here, let's try Sammy. Can Sammy fetch? Well, we haven't defined this fetchability function under Samoyeds, and it's not defined under the superclass dogs. So when I call Sammy dot fetchability, it would actually come out to an error because this function is not defined under Samoyeds. But if I have Goldie, it actually inherits both of these from the parents. So we can call its fetchability and its shedding. So we can print Goldie dot shedding amount. And we can also print Goldie dot fetchability. And here we get a shedding amount of 0 and a fetchability of 8 because Goldie is less than 2 years old. Ta-da. Okay, so just to quickly sum things up a little bit, inheritance means that you have children classes that can actually inherit properties from parent classes, and then multiple inheritance means that you can actually have more than one parent, where the subclass will inherit from all of the parents. Okay, so let's talk a little bit about polymorphism. Now, what in the world does polymorphism mean? Polymorphism quite literally means the ability to take multiple forms. From an object-oriented standpoint, this actually means that a child class that inherits a function from maybe the parent class can override that function and give that function a completely new set of rules to follow. So again, let's do an example with our dogs. Under our dog, maybe we can define our bark. All dogs might bark like woof. So we can return woof as our bark for all of our dogs. And that's just our default bark. Okay, so we have Sammy and we have Goldie. Let's just see what their bark would sound like. Okay, so we're printing Goldie's bark and Sammy's bark. And both of them are woof. But we can actually change this for subclasses and make the subclass follow a different set of rules. Come down here and I define bark. This is polymorphism because we can actually override this and we can say arf arf maybe. Whereas maybe a golden doodle is saying something like aroo or something, I don't know. Now, let's listen to these dog barks again. And just for comparison, I'm going to create a new dog object. Generic doggo equals dog, and I'm going to name it Gene. It's going to be 10 years old, and of course, it's 10 out of 10, a good boy. So we're going to also say this generic doggo dot bark. Okay, so we're doing Goldie, Sammy, and then generic doggo. So we see that Goldie is now barking like aroo, but then Sammy does arf arf, and this generic doggo goes woof. This is not a very complicated function, but it is still a function that we are overriding. Basically, we're saying, hey, for this specific type of dog, because it's in the subclass and we've given it new instructions, ignore the parent instructions and follow these instructions instead. So for any type of function that's even more complicated, we actually don't look at what the parent has. And this function now takes a new form, polymorphism. So these are kind of all the building blocks of object-oriented programming. With inheritance and polymorphism, we can get rid of repetitive code and organize our classes better. And we can also have the flexibility to change any of the functions to make sure that they are actually doing what we want from a lower class. How cool is that? Anyways, thank you guys for all joining me for my beginner Python videos.
Okay. Whenever you are done, take your time. Whenever you are done, please type 1. Kylie, Sherry, Samuel, Daniel, Alexis, Matthew, Lyson. Okay, awesome. Murad, thank you. I have watched many explanations, but this one was one of the best. I think that it really deserves to watch a few times to get the idea. Well, the second one, that's almost 20 minutes. One is a little bit advanced version, and this is can be used as a kind of review. Let's quickly go through the things that we are going to have in today's session. The before I continue again, for those who joined us later, this is the code at class code. So the applied objectives for today is define and use a subclass that inherits a superclass and overrides one or more of the methods of the superclass. So you can see that there are several names that we use. We say superclass, we say parent class. Rarely I saw master. And we call the class which is derived from the superclass as subclass, as child, as a derived class, or rarely slave. Define and use a class that overrides one or more methods of the object class. The reality is everything that you can find in some advanced languages like Java, C#, you can find a simplified version in Python as well. But finding exactly similar functionalities that you could have there is not possible. And I'm going to elaborate on a few of them without confusing you, but by going to details. So the knowledge objectives are describing the way inheritance works. In general terms, explain how to override a method in the superclass when you are defining a subclass. The way like dog sound in the video that you watched. So how you just say bark in the general class, in the base class, and how you override in subclasses, like for golden retriever or Samoyed or the others. Describe the concept of polymorphism. And she told already poly means several or some. Morphism is shape, so many shapes or several shapes. Describe the use of the isInstance method when working with objects. Describe the use of the object class and these methods of the object classes like stir, iter, and next. Describe 3 factors that help determine when it is appropriate to use inheritance. If you see that I do not focus on some of them, we are not going to have them in the final exam as well. I want to make sure after finishing the semester, if you go to any interview, the high probable questions that you might receive, you have enough knowledge to answer them. You know that we talked about UML diagrams. So if you have a product, for example, as a base class, you see that book and movie classes, they are derived from the product class. So it means that for both books and movie classes, we have name, price, and discount % for sure. But apart from it, we could have author in addition to the fields that you see in here for book, and you can have year for the production year of the movie apart from, or better to say, in addition to the fields that we have for product. you can see that we have get description in book as well as movie classes, but we have that in the super class. So the question is why we repeat that. Based on the definition that we watched in a clip, you can understand that we want to override them and have a specific description for book as well as for movie, movie for the time that you want to have a book instance or a movie instance and not a general product instances. So the UML diagramming note shows that to indicate that a class inherits another class, a UML diagram typically uses, as you see, an arrow with an open arrowhead, not a shaded arrowhead, as shown in the previous slide or previous content. So let's just get to inheritance. Look at here. Generally, whenever you want to define a class, defining a class is similar to defining a blueprint that you want to create objects based on that later. Question, are we going to have any place, any specific place in the memory for just class? Whenever you are not created, you didn't create any object out of that class yet. As Samuel correctly said, no, we are not going to have any memory. And Simon correctly said, not until constructed. That's what I actually wanted to hear. Awesome. Thank you, Simon. And Samuel said, only when you create an object. So the question is how we can create an object, and that is the responsibility of constructors. In other languages, we have several constructors. We could have several constructors here, but in Python, we only could have one constructor per class. So you could say, what if, Reza, I want just to pass name and age and not, for instance, a student number or last name and the other things. In such cases, you need to have default values for those that you do not want to pass as parameters when you want to create a new object. I repeat it. So because we can just only have one constructor, for those parameters that you are missing to pass, you need to have initial values or default values for the constructor. We are going to get to that in no time, so don't worry if it is not super clear at the moment. Then we are going to have our methods. Some people believe that constructors are type of methods, and they are not far from the truth. Also, we are going to have encapsulations to define accessors for the properties. And whenever you say property the way that you see here, it means that a getter part and the other part would be a setter part. And if you have questions about this, I strongly suggest that please review the interactive Python notebook that we shared for the week number 11, or if you need further information, you can just rewatch the recorded video. But let's jump into one example together, and let's create a class called animal. And you see that we have a constructor, and as a part of any method, including the constructor that we have, we need to say self, and self is something like this in C# or Java, and it addresses the current instance that you have created based on the class. So you see that here, the name could be, that's the default value, nothing. The gender could be nothing. The weight could be 0, as well as the height. Means that this is going to provide us the facility of having auto-implemented constructors like what we have in Java and C#. So the question, if you receive that question from anyone, okay, what if we want to have a parameterless constructor? What is your solution? We know that we do not have auto constructor the way that we have in C# or Java. So what is your solution? The answer is we are going to define underscore init underscore self, and for every single field that we have, we need to pass default values. We could ease the job for ourselves to say for names, it could be nothing, the string that contains no value. And for the other numerical values, we pass zeros. If it is clear for you guys, please type 1. Ellie? Murat? This is Matthew. Okay. Michael? Awesome. Look at the next one. Everybody, can you please tell me why we have underscore? It goes back to the previous session. Whenever we have underscore, what does it mean? Excellent, Alexis, Sherry, merci. It means that there are private fields. Okay, so pressing Shift and Enter, and then let's have a drive class. If you don't want to change anything in your derived class, simply you can say what? I have a class named dog, and it is derived from animal, and then I don't want to do anything. So if you don't want to get any error, you just simply say pass. And you sit like that. Okay, here it is something like when in other languages you say animal, the name of a the name of an object, and then you say new animal and then this thingy. This exactly means constructor part. Here it is very simplified. You just say the object is created based on this class, as simple as this. Now I created that. And do we have any name for animal 1? No. Do we have any gender, height, width? No. But for animal number 2, you see that we pass all those values. And if we say print animal 2 name, it's going to say lion. What do you think if I say dog is equal to dog class and I pass nothing into it? What would be the name of the dog? Can anybody guess? Please. It's not a trick question, guys. It is simple. Yes. If I say, guys, look at the definition of animal. For the name, if I don't say anything, what is the thing? I'm talking about animal. For the gender, for weight and height. Imagine that I define a class, an object based on the dog class. What is dog class? The dog class is inherited from animal class. So if I don't apply any name to that instance of a dog, what would be the name of the dog? Exactly. Exactly. Empty string. All of you said the correct thing. The default is nothing. So the combination of all you said. So that is why if I say print the name, it's not gonna show anything to you. But imagine, guys, because I'm lazy, I just copy this one. And just in here, I say Dogo. And now if I say it's going to have Dogo, right? Okay. Look at this one. It really depends what you want to get Sherry. Here, we wanted not to make it compulsory to define a name, right? So if for any reason you miss that part, it's gonna be nothing for the name. Does that make sense, Sherry? In here, if I just, okay. So if I don't have anything and I ask the question again, no worries. If I ask the question, I say, create a dog from the class dog and show me the name. This time it's going to be nothing, right? The default value, as all of you mentioned, would just jump in. But what if apart from the all the fields like name, gender, weight, and height, I want to have the number of teeth for the dog class. In that case, look at this one. I'm going to have that init constructor. I'm going to have that constructor. One of the ways, I'm not saying that's the best, we are going to see all the possible ways, so don't worry, just accept this temporarily for now. But you remember, I think that the name was Kaylee. Kaylee explained it using super, but it is possible to name the superclass, which is an animal here. And in that case, you have to borrow that self here too. And then which one is not there in the animal class? It's teeth. So whatever you do not have in the list of fields that you use in your constructor of the superclass, you are going to add them here. Guys, I don't need to have everything. So that is one of the ways that you can simply recognize if somebody is not a real object-oriented programmer. They're going to repeat all these fields. We don't need that. We just add the one that does not exist here. So now, if you haven't copied, the same as inheriting in C# using base. Lovely. Yes, exactly. I try to be a little bit considerate for those friends that they have the concept of object-oriented in other languages like C# or Java. I quickly just say the similarities, but at the same time, I do not dive deep for those people that for any reason, they didn't have that background. So they don't feel that they really need those prior knowledge. So there is no prior knowledge for object-oriented in Python. So everybody, please open the download if you haven't done it yet, because I saw that now we have quite double the number of people that we started the session. So you see here we have animal class. So drag and drop that into, after you decompress, unzip the file, drag and drop it here. And oh no. If you see, I just wanted to define a simple, we actually have two simple classes. Look at them. One of them is my animal class, and the other one is my dog, just to make sure that we don't use the same names. So they are totally different classes compared to what we have met. I mean that the source is not these dog and animal classes. So the same way we define my dog inherited from my animal class, and we just said similar things. We just want to practice what if you define a class, a superclass somewhere else, and you want to import them. So as you see, I said from animal class, import both my animal and my dog. So if you run that, and then we say new animal one, it's an instance of this class, my animal. So new animal two, so we have Pink Panther, and those are the specifications. You can simply, you don't need, you know better than me. If you just say, for instance, dot, what is the thingy? The name, for instance, right? So it's gonna show you the Pink Panther and the rest. So I don't want to take a time for such things. In the next one, we have all those fox, female, and the rest. For the cat, we just have the name, but we don't have anything for, I don't know, height and width. What are the, yes, height and width. And for the dog, we say golden retriever, female, so 175 and 100, and the number of teeth, 50. So how about the other dog, which is a Labrador, and it's male and 90, and the last one, we just say husky, and we leave the rest as the values that you can consider will be filled by the default values of the constructor, okay? So I wait here. If you could finish everything till this moment and everything is super clear, please type 1. If you have any concern or question exactly relevant to these things that we have already covered, please ask. To let you know, the lab for this week is designed exactly to cover all these content, all the things that we cover in today's class. So you can intensify and work more on the concept in the coming lab with Prof. Maziar. Okay, so how about the method overridings? Imagine that we have something like get name in the animal, my animal class, right? Let's just define from the scratch my animal. So forget about the file that we had there. And then we say get name. Look at this one. Here I pass self. Here I'm gonna say the name of the class name instance, for instance, is gonna be the name of the my animal instance is the name of the animal that you created. And is female is going to be if self.gender, the length of it is equal to 1, guys. Look at this one. I want to say if the gender's length is equal to 1, means somebody has entered either F or M. And the ASCII code for that is either 70 or 102. Look at this one. Sorry, I needed to bring another keyboard that has numerical pad on the right side. It doesn't work with the numeric keys on top of the keyboard. So you should have, if you want to see similar thing. Look at this one. If I press Alt and then press 70 and I release the Alt key, I'm gonna see F. If I say again Alt and 102. This time it's going to show small f. You see that? So that's a nice way of saying if the ASCII code of the gender field is going to fetch the ASCII code or the Unicode. That's the most recent version of, yes, you're absolutely right, Alexis. If the Unicode, we say always ASCII code, of the gender is equal to 70 or 102, then means it is capital F or small f, then say yes, it is true, else say no, false. It could be because you have entered more than one character, or you left it as default, which is nothing there. So it's going to show you false. How about this one? My dog is inherited everything without any change from the my animal, except that we have this extra field, which is teeth, and we get that from the user when we initialize an object. So let's go. Apologies. So did I run? No. Run this one and run this one. And now the animal, yes, we created one with all the features, and then dog with all the features except the number of teeth. And then here we say animal.getName. Look at this one. It says that my animal getName result is, this is this part. Go to the new line. And it's going to show you the name of the, look at here, the name of the my animal. That's the class name. My animal instance is pig, and that is 100% correct because we just said pig as the name of the animal. And here, because we said M here, so it is false. It's the animal is not she, so it is he. So the pig is a male pig, and that is why we have false over there. Does that make sense? How about the my dog? So for my dog, we have it inherited from the superclass. So it says that my dog gets name result is, that is from here. Go to the next line. And we say the name of the my animal instance, look at this one. So it shows that we generally trigger the parent class name, and it is obvious because it has inherited from there, is golden retriever. That's the self kind of thing. Look at this one, self instance kind of name. So here we talk about the superclass. It has come from there, and we didn't override anything. So it comes from there, right? And then let's just see that golden retriever is female. So if you check, say, dog is female, it's going to bring you back true. Because the ASCII code, or as correctly Alexis said, the Unicode of this is 70, and we have it there, okay? So if everything is clear till this moment, please give me the first high five, type 5. Matthew, Kylie, Murat, Sherry, Simon, Alexis, Michael. Okay, awesome. So by saying that, it's already 2:50 almost. So let's have 10 minutes break, and then we are gonna come back and continue at sharp 3. Okay, can you hear me? Mr. and Mrs. Park? Okay. Um, it's not the only possible way. That's a good question. Why we use ORD? If you search, ORD is responsible to get a character and returns a Unicode of that, right? You could simply just say if it is equal to capital F or small f. That's one of the just ways that we could do. It's not the best, it's not the only, but thanks for asking. And I leverage the time. I use the time to say, this is actually the beautiful thing in programming. We want to get to one solution, but there is no only one appropriate way. So we can have different approaches. The best is the one that has the highest efficiency, and the data structure course tells you about to have a better solution, that the big O is smaller for such cases. Okay, thank you guys. If you can hear me clearly, please type 1 and we are going to continue. Thank you, Kylie, Matthew, Tamer, Murad, Joe. Okay, look at the next one. In the next one, actually, we defined something in the subclass, child class, derived class, which we do not have that in the parent class. Let's just run these. The reason that I repeated everything several times is if you just join the class and you want to continue, and you're not going to face any error then by just running the same code. So we said that the first dog from my dog is female and the second dog is male. So if I check if the dog can be, the thing is, we say that can be a mother, has come from one fact. If that dog is female, and we know what female is, checking the gender field and see if there is only one character, and if it is either small f or capital F. If that is true, then return the dog. For instance, first dog, second dog, whatever, can be a mother. In this toy example, first dog can be because she is female, and the second one cannot because the dog is male, right? So by saying that, if you say, so print first dog can be mother, we can expect to receive true. And the second one should tell us that cannot be because that's M, male. One of the things that some of you participated and correctly said, these fields that they started with underscore underscore, they are private fields, and we cannot simply say, for instance, show me the weight. It is not possible because they are hidden, as you see here. So for such cases, the only way to set after initialization or after creating an object would be setting setter getter. To set or to get the values could happen only if you have properties, or in other words, setter getters. That's one of the pillars of object-oriented, which we know as encapsulation. Let's go. See, if I say, show me, well, create one object, it is created by passing all those parameters. But if you say, get the weight value for me, it shows error, as you see. And if I create another dog. This one was animal. This is from the derived class. It does the same thing. So now we get to the part B of presentation, and that would be the time that you want to define a getter by just simply saying at property, and defining setter by saying the name of a field dot setter kind of thing. Huh? Okay, just remember this format. One of the thing is, that's what I always recommend our friends. If we want to use internet in a constructive way, guys, nobody expects you to remember everything. So you just search property, setter, getter, Python, and you're gonna have exactly the same concept. But if you see a problem statement and you just drag and drop it to ChatGPT, well, you're not gonna get the concept that, right? So this is how we define properties for the weight, right? Setter, getter, and it is going to get inherited from the animal class, my animal. And then if you say now, show me of the weight, remember, for this one, actually, we call which part? We call the property, not a field. So that is why it's a gateway to get to the field. One of the questions that people could ask you in the interview questions is this: which one occupies memory for you, fields or properties? Guys, what is your answer? Which one occupies memory for you, fields or properties? Lovely. Yes, exactly. Fields occupy memory. So in that case, what is the role of, I'm sorry, what is the role of properties? You could say there are gateways to access, the memory location. So you can have more control, and in terms of security, they are higher in terms of security. You can just check any condition before getting the values. Okay, so for this one, the same way for the dog, which is derived from that class, we just access the weight, but through the gateway, which is called properties. This is another class, actually, to review. I borrowed it from one of the sources. I want you, please, spend a few seconds and read this one. It is very simple. We have three fields here: name, price, and discount percent. Also, we have three methods. One is going to calculate the discount amount by passing, look at this one, the price, multiply the discount percent divided by 100, right? And then the actual price after discount would be the original price minus the discount that you calculated in a second ago. And the description, for the sake of simplicity, we just say, let's say self.name. That would be enough. So you see that I have defined two other classes. They both derived from the product. And the first part, we used product __ in it. Self, if it was super, we don't need to have self, and we pass all those things. And now look at the polymorphism. For get description, we return that get description by the book's author. So you see here we override the original get description that we had in the parent class. We do the same here by saying the name of a movie plus space. We have open parentheses, and then we say stir for the year, because originally the value is an integer number, and when you want to concatenate the way that you see it in here, you should convert it to string, and then you're able to add them together. Okay, so these samples, I have borrowed them from the original textbook that you have. Again, I pass for those friends that they just joined the class. This is the zip file. I want you, everybody, those who attended sooner, everyone, please now go to File and then say Upload Notebook. The other way is saying Control-O and then click on Upload. And please drag and drop this, the second file, which is week 12 Python B complementary. Take your time, and whenever you could do that, please type 3. Thank you, Kylie. Akoreda, Alexis, Sherry, Luisa, Mustafa, Solomon. Okay, awesome. To give time to more friends to join, and those who joined later, this is the add class code again. Okay, so we have a class called employee, and look at this one. We have a class level. This is something that we could call static in other languages, huh? So we have a class level variable, which is 1.04. We say raise amount. Okay, so imagine that normally we consider 4% for all employees in different departments. But what if we want to have exceptions like the demand? Imagine, guys, partially it is correct. Imagine that we see that the lifespan of having developers in a company is shorter than normal. And the reason for that is they receive higher offers, and then they go to other places. So we are going to have exception for developers, for example. Let's have that scenario and then continue. Imagine that the first, last, and the pay are as you see here, but we have another field, which is going to be the combination. Imagine that you get to George Brown and they get your first name and then dot and your last name and add georgebrown.ca kind of thing. So we are going to have similar idea here if it is not duplicated. So what is the method full name doing for us? What is it doing? It returns first name space last name dot format self first, comma, self last. And you know better than me that whenever you have curly braces, it's like old-fashioned C, or still it is valid in Java and C#, like you say 0, 1, so it goes to the first and second parameters that you have in the list. It does the same thing. And if you say that define a method and apply raise, look at this. Whatever the pay hat would be, you're going to say the int, you don't want to have the decimal point, right? You just want to have the integer. You say whatever the pay is, multiply it by 1.04. So imagine that if somebody receives 1,000, it's going to be 1,040 kind of thing, right? Okay. So how about this one? You see employee 1 receives 50 and employee 2 receives 60. And the email for the first would be curry dot, look, I'm sorry. And the email for the second one, test employee, would be like that. For the developer, if you say nothing and you just say pass, it's not going to do anything. So imagine that you want to, Joaquin Phoenix receives 70,000 and Keanu Reeves receives 80,000. So you can just have their emails as you see. And there is something that you can extensively go through. If you say help developer, the beautiful thing is it's going to tell you where it has come from, what are the methods, and everything that you could have is explained. It's like having the access. Imagine that you just don't want to scroll or to get to the source file. You just want to see how was it, what was it, and how it works. So you can just simply type help, the name of the class, right? It clearly says the class's developer has come from employee, and we have first, last, and pay, and the rest of the things like the init that we have, the raise and the full name kind of thing. Okay, so everybody, if you say how much was the person, Joaquin, how much he receives, 70,000. And if you say, okay, what about if we give him a raise? And after that, 4% is gonna get applied. And then Joaquin Phoenix is gonna receive 72,800. But right now, I am going to define a developer class. It's better to say redefine, saying that the raise amount is not enough for developers. Let's consider 10% raise. And imagine that we have another developer. The name is Richard Tenay. And Richard Tenay received 70%. And if you say, show me the name, it's going to be Richard Tenay and 70%. And if you apply the raise, guys, what do you think it's going to show? 10% of 70, it's going to show you 77. Does that make sense, everybody? Take your time, spend 1-2 minutes, go through the code since the beginning, all the way to line number 20 that we have gone through together. Whenever you are done, then type 20. Take your time, no rush, go through them. Sherry, Kylie, Matthew. Justin. Let's have a few more friends. Simon, Justin. Oh, we have two Justin. Okay. Listen. Loyalson, I'm not mistaken. Okay, so let's go and see. Guys, what is not very great about this? I intentionally have, okay, you might say, compared to what? Okay, imagine that this is a class employee and here I have this one. So please compare. What is not great about this child class? Bravo, Simon. Let's see if more people can relate to that. The whole idea of having inheritance is to define something similar to all children classes in just one place. You remember, I think that she was Kaylee, if I'm not mistaken, the amazing instructor who explained at the beginning of the class. So she said that imagine that we have different breed of the dogs. We are going to collect everything which are common in one place. Huh? So that is why in the case that you see here, for instance, everything is repeated like the original class. It's useless. It works. I want to share that it works. The only thing which is extra is programming language of the employee. And for instance, Natalie Portman, she is a Python person and she gets 90,000 and that's her email. So let's just go through it. It works. So, but I'm saying a better, not the perfect way of saying that would be like this, saying a class developer is inherited from employee, and this is, guys, I have forgotten the name of, what do we call this initial values. What do we call this block? Start with C. Lovely, Sherry, thank you. Constructor. Yes, constructor. So that constructor, we say, hey, go to the employee constructor, and there we have, if you look at this, there we have sell, first, last, and pay, exactly the same way. So you don't need to, technically, we save our energy for these lines for all this. And the only thing that we added would be that programming language that we pass to self.prog.lang. And we can define Juliette Binoche as a C# programmer with 95, right? And that's her email. But what about this one? Guys, in here, we say a developer is derived from a class employee, but this time that's the best. It's like a professional way of saying that. Saying super, dot in it, and you don't need to say self again. You just say pass, first, last, and pay. Guys, I tried to meticulously pick the words, so I said more preferred. We could say professional way, right? Of using inheritance, using super for accessing the parent's constructor. By saying that, imagine that we have Robin Williams, and he's a C# programmer, and then the email of Robin is this, and that's pretty much it. But now we want to define a class manager, okay? So take your time. We have gone through a few more lines. Whenever you could get to that part, it's going to be line number 26. We shouldn't have that. It's not the matter of necessary or not. We shouldn't have that. Yeah. Actually, no. Okay, Kylie, please accept this short answer from me, and I'm more than happy to discuss further what I'm going to explain to you in the next few seconds. Imagine that you have, give me a second, I'm sorry. And this question is very much, oh no, please. Okay. Imagine that we have a super class. I intentionally want to bring you to a place that we have a class like product. Imagine that we have a table. The name of a table is product. And then imagine that we have one table, which is order. Does that make sense? We have a table, which is called order. And I'm gonna just, to accelerate the job, I'm gonna just write it. In the product, we have something like product ID and so on and so forth. And we have something like price, unit price, a simplified version. But in the order, you have order ID, right? You have product ID as the foreign key. And you have number of items, for instance, number of items. And here, do you really need, can you, Kylie, please tell me, do you really need to have total amount here, yes or no? Because total is technically is nothing but number of items multiply the price that you have in other table. Do you really need to have such a thing here, total in order? Yes or no? Lovely. That is absolutely right. Theoretically, and as a person that I was fresh out of the school and I get to the industry, I was like that. So we don't need to have total because we have the information of the item numbers here and the price here. So redundancy is kind of no in all the cases. Surprisingly enough, most of the cases we use total, right? We use total. Why? Because there is a chance that we have a Black Friday, and in that sudden cases, the price is updated to something different. So finding and going to that specific day based on the issue day of the receipt is a kind of cumbersome process. I'm not saying that it is impossible. I'm just saying it is a cumbersome process and could have errors. That is why in such cases, we accept the redundancy of keeping total for such cases, right? So there is no general yes or no to your question. We need to consider cases like that. The other thing, for instance, for the email address, because we always use, for instance, first name dot last name. Imagine that we don't have any scenario that we have repetitive names in our database, which is not true. So we just don't need to have that. I hope that I answered partially your question. For any further answer, I'm open to discuss after the class. My pleasure. So let's go to the next part together. So here you see, we said that we have super, and we talked about Robin Williams, and now we get to class manager, and in the class manager, actually, we have a new thing, a new field, and that field is employees. And employees, we mean that we have a list of employees. So we are going to get everything from the parent class employee. And if the employee is none, which means that we haven't defined anything, then just consider a list of empty. Imagine that we have a manager that no employees assigned to his team yet, right? Otherwise, if the manager already has, so bring the employees, the list of employees into self.employees kind of thing. And we could easily say whatever the employees you have, we can add a new crew to your employee team. And if you already have a lot and we can just use some part of your employees in other projects, let's remove those that are not fully assigned project portion to them, right? So this is going to be remove employee, and whatever you have, you're going to remove that from the list. Guys, this is simple. We just use remove method. That is a kind of list method kind of thing. And what about print employees? Very simple. We are going to have for every employee in the self-employees, please show that arrow kind of thing that we created, and then full name. And full name means that call this thing that we have in the parent class. I should go all the way up. Yes, which we are going to use first name and last name. So without any further delay, after running that, let's say we have a manager, Sue Smith, and Sue Smith has one developer. And manager 2 has developer 1 and developer 2. Guys, imagine that developer 1 works for both teams. And then manager 1, we say add developer 3 to the team. So how many developers the manager 1 could have? 2 already. And if you say manager 1, please show the whole, so you see that Joaquin Phoenix and Richard Haney already applied to manager 1. And if I say remove developer 2 from this team, actually we had just developer 1 and 3, so it's not going to change anything. Still, we have those 2. But if I say remove, for instance, Richard Haney, developer 3, from the team, and if I just see, it's going to show me that we have only Joaquin Phoenix in the list. Okay. So this is kind of technically the second video implementation. I tried to get the gist of the thing and make it kind of hands-on. Hopefully you could just follow everything alongside with me. Guys, if you could finish the things that I have mentioned, whenever you could finish, please give me high five, the last high five, type 5. Thank you. Bravo. Merci. The last thing that I want you to please do is go to the please go to the assessments and then to the quiz and see if quiz number 9 is available for you to start. Excellent. Thank you very much. I hope you enjoyed today's session, and I'm 100% confident that Maziar is going to work on the concept, and you're going to enjoy the labs in this week as well. Have a wonderful one. And if there's no question or concern, guys, see you next week. Take care. My pleasure, Kylie. Thanks for asking. Thank you. Bye.